So now coming to the second question, the question is if you would have solved it, you would have found that we can easily solve this question if we use the parametric form of equation of line. So few of you may think that how could I realize or how come I know that we are going to use or we should use here parametric equation of line. So for that I will tell you one statement which I always tell to all my students and which I always follow whenever I have to decide whether I have to use parametric equation of line or not. Because see, parametric form of equation of line, we don't use it in like so commonly or so frequently. We use it only in a special case, and that's the special case here. Okay, let's start. Variable line passing through a point P. First thing, there has to be a fixed point through which a variable line pass, if at all. You have to think of applying using the parametric form of line. That's the first thing you need to know. Variable line passing through a fixed given point. The point has to be given. Okay. So variable line passing through this point intersect the curve, which is a circle. Doesn't make any difference which curve is it. The equation matters, which is given at A and B. Consider a point Q on AB such that PA, PQ, PB are in HP. Find locus of Q. Okay, so what are we given here? We are given here PA, PQ and PB are in HP. So what does that mean? 2 upon the middle term. 3 numbers are in HP. If their reciprocals form an AP, isn't that? So 2 times the middle term is equal to the sum of the first and the last term. Now look at this expression. See what I say, that's what I said. I will discuss it. Whenever distance from a fixed point, whenever distance from a fixed point along a line is required, imply start with parametric form of equation of line. So start with parametric form. See, that's what I say. Form of equation of that line. That line means which line? That line means this line along which the distance is required. So distance from a point, from a fixed given point along a line. That holds the key. This statement holds the key, bachon. Okay, so whenever we need distance along a line passing through a fixed point, and now why are we using parametric form, or how can we use parametric form? The point is simple, because of the parameter. What is parametric form? So if the point, the fixed point through which line is passing is this, then its parametric form of equation is x minus x1 by cos theta is equal to y minus y1 by sin theta is equal to r. Now what is r? R is the parameter, and its geometrical significance tells us where to use it. So what is its geometrical significance? Its geometrical significance is, see, we have infinite many points on this line. What is theta? Theta is of course the slope angle, so tan theta. So theta is nothing, the angle which we have considered for slope, tan of theta. That theta is to be used here. Okay. Now what is parameter r? Geometrically. So geometrically, if there is any point, variable point x comma y, this x comma y, then it is as a distance of r from the fixed point along the line. So r holds the key here. What is r? R is the distance of any variable point on the line from the fixed point. So whenever we need this distance from the fixed point along the line, what are we using? We will be using r. To use that r, we need to use the parametric form of line. That's it. Okay, so whenever distance along a line from the fixed point is talked about, is required, is to be used in the question, I will start with the parametric equation of the line given the fixed point. Okay, so here the fixed point is given, and that fixed point is 1, 2. So let's start. See, that's the curve. So as I say, I just draw a rough curve, so don't take it seriously, because it may happen that 1, 2 lie inside or outside the circle. I am not going to check it. So it intersects the curve at A and B. Is it a fixed line? No, it's a variable line. Why is it a variable line? Because slope of the line is not given. We know through a point we can have infinite lines, so we can have infinite pair of A and B here, bachcho. Okay, so now what? So now what are we going to do? So of course I will be starting with this parametric equation. What will that be? X minus x1 by cos theta is equal to y minus y1 by sin theta is equal to r. R is the parameter of the equation and r is the distance of any point on the line from the fixed point P. Okay, now one very important thing I think I missed to discuss, how does that I got that hint of using parametric form? Because of this PQ, PA and PB. Aren't are all these three are distances from the same point P along the same line. Okay, PA is this distance, so this is some distance, PB is some distance, and there's some point Q here, so that's another distance, isn't that, bachcho? So that's another distance. So since all these three terms PA, PB and PQ are distances from the fixed point along the line, that's why in the very beginning I said I will be using the parametric form of equation of line. Okay, so now, so therefore I will write a variable point. I can't use P here, so I'll use some other point. So let variable point V be. That means I'm going to get x and y. So x is r cos theta plus 1, y is r sin theta plus 2. Isn't that? Now put these since we need point of intersection, yeah, curve is x square plus y square is equal to 1, and since I need the points of intersection, so of course I need to put these coordinates here, because to get A and B, to get any information regarding A and B, I have to use the given condition, and that is the line intersect the curve at A and B. So if this is any point on the line, so to get point of intersection, I will be satisfying these points in the equation of the curve. What am I going to get? So it's r cos theta plus 1 whole square x square, r sin theta plus 2 whole square y square minus 1 equal to 0. Now what do we get? We get a quadratic in R, and that's expected, and that that's what we will get for sure. See, if we need 3 points of intersection, so that means we need to get 3 different R, because see, PA is some other distance from the point P, PB is some other distance from the point P. So to get A and B, we need to have 2 different R, 2 different values of R. So that's what we will get when you get a quadratic. So for 3 points of intersection, we need to have 3 different R. To get 3 different R, we need to get cubic. Okay, so we know it beforehand that which degree equation are we going to get. So I knew that we'll be getting here a quadratic equation is R. So let's get it. So R square, because sin square plus cos square is 1. Okay, plus R times 2 cos theta 4 sin theta, 1 got cancelled, plus 4 equal to 0. Fine. Now I will say let this distance be R1. So let me use some other color here. R1, which one? PA. And this distance be R2. Okay. So R1 plus R2. So that's what we need here. What do we need? Just a minute. Yeah. If I solve it, so this is 2 over PQ is equal to PA R1, PB R2, PA into PB, product of roots R1 into R2. Okay, so that's why I will write here sum of the root. How much is it?